So this is 5-8, the quadratic formula. It says solve the equation using the quadratic formula. So the first thing I'm going to do is write that out. I'll go ahead and sing it. We have x equals negative b plus or minus the square root b squared minus 4ac all over 2a. There you go. There's the formula. Write that down. And I'm going to go ahead and fill in our a, b, and c values right now. So I have a equals 3, b equals 5, and c equals negative 8. The reason it's negative 8 is because I subtracted this 8 over, and it's actually, I'm going to write it up here, 3x squared plus 5x minus 8 equals 0. You want it equal to 0 when you're doing the quadratic formula. So I put this 8 on the other side. There you go. So I'm going to go and use these values. The first thing I'm going to do is I'm going to use just the discriminant. Remember, the discriminant is this part right here. And that part is going to tell you how many solutions you have. Make sure to reference your notes for that part. So when I plug into that, I have 5 squared minus 4 times 3 times negative 8. And you can just put that straight into your calculator, and you get 121. Now, when you have a positive discriminant, that means that you should have 2 answers. So, that means I'm going to have 2 answers. Go ahead and pause and write that down because I'm about to erase this. So when I plug it into the whole formula, I have x equals negative, b is 5, plus or minus the square root. And then when I did the discriminant, I got 121 all over 2, and my a value is 3. So when I simplify that, we get negative 5 plus or minus, what is the square root of 121? Think about it. 11 all over 6. So I can actually get 2 answers from that since I have it. If you're left with a square root in your final answer, totally fine. But here, since I can do numbers, negative 5 plus 11 is 6 over 6 is 1. And negative 5 minus 11 is negative 16 over 6. Those are my 2 answers. So I just simplified it. One of them using the plus sign right here, and the other one using the minus sign right there. So there you go. So I'm going to go ahead and do complex numbers on this video as well. When you see the square root of negative 1, it's always I. That is the definition of I that we are using. So when you see square root of negative 25 right here, we know that the square root of negative 25 equals square root of negative 1 times square root of 25. So that means the square root of negative 1 is I. The square root of 25 is 5. So it is 4 plus 5i. And then the square root of negative 100 is going to be 10i. Because the square root of 100 is 10, and then the negative makes that an I. I stands for imaginary numbers. Now, when I do this problem, I'm going to go ahead and multiply right there. So that leaves me 40i. Remember, you treat I like you would x. So then I just have I, and then I have 50i squared, because I times I is I squared. Now, we have the definitions up here. If negative 1 equals I, then I squared equals negative 1 times square root of negative 1 times the square root of negative 1 is just negative 1. So really what I have is 40i plus 50 times negative 1, which is 40i minus 50. That is your answer. So go ahead and do that one. And then down here, I have simplified the expression 7 plus 9i plus negative 5i. Remember, you treat I just like you would x. So I'm going to go ahead and combine like terms here of 9 and negative 5. So I get 7 plus 4i as my answer there. So that's the beginning of complex numbers. I'm going to go ahead and do the two other ones as well, just to help you out. So right here, number 51, it says 3i squared. Notice how the squared is on the outside. So what that really means is you have 3i times 3i. So just that part is 9i squared. And I know that I squared is actually negative 1. So that's 9 times negative 1. So negative 9, all for this term right here. Then for the rest of it, I'm going to go and distribute right there. So that's minus 3 minus 15i. Whoop. So if I bring that down here, minus 3 minus 15i, that was already simplified. Negative 9 and negative 3 combined to give you negative 12. And then there's nothing for the negative 15i to combine with. So negative 12 minus 15i is your answer there. And there's the bell. So now I'm going to solve the quadratic equation. And considering we're in the complex number section, we can assume there's probably an I. The first thing I'm going to do is I'm going to go and put that 6 on the left side of the equation. And I'm going to go ahead and do the discriminant. Oops, that's an equal, sorry. I'm going to go ahead and do the discriminant. Remember the discriminant formula is b squared minus 4ac, where a is 7, b is 8, and c is 6. So that means that I'm going to have 8 squared minus 4 times 7 times 6. And that's going to give me negative 104. Now, we talked before, if you have a negative 104, that typically means you have no solutions. However, you have no real solutions. Now that we know that the discriminant is, I'm going to go and put this right over here so I can erase this. Now that we know the discriminant is negative 104, when I plug it into the quadratic equation, make sure you see the quadratic equation on the previous video. You have x equals negative 8 plus or minus the square root of negative 104 all over 2 times 7. So what that's really going to look like is x equals negative 8 plus or minus, you can come in, that's fine, plus or minus I square root of 104 over 14. So just leave the I out there and then the rest of the problem is fine.